Hi sir, my name is Raja Balasubramaniam and today we will see about experiment 3 which is application of first and second law of thermodynamics. We are from group 8, our group members are Aida Zahira bin Azhar and Amirul Hakim bin Hamizan and Muhammad Amin and also Naveen Raja is me doctor. So let's get started. About the abstract, this experiment was conducted to apply the first law of thermodynamics and the concept of the second thermodynamic law in process. In this experiment, the mass of two different sizes of containers were taken. The large container was filled with a little amount of cold water and the smaller container was filled with hot water which is approximately 80 to 90 degrees Celsius, and the mass of cold and hot water was taken respectively. Then the hot water container was placed inside the cold water container. The reading of both water temperature for every 1 minute was noted until it reached the same temperature, which means it reached their thermal equilibrium. At the end of the experiment, we noticed that the heat can be transferred from the hot reservoir to the cold reservoir easily without doing any work. However, our result may differ from the theory due to some errors during the experiment was conducted, due to some parallax error.
Okay, for the introduction part, a compressor is a system that reduces the specific volume of compressible fluid, such as a gas or vapor, in order to increase the velocity of the fluid to pass through the compressor. One of the primary goals of using a compressor is to compress the fluid and distribute it greater pressure than before. For the experiment, we use the compressor for the objective to apply the law of thermodynamics and the concept of the second thermodynamic law in the process. And we also identify that how heat is converted to work in a single stage compressor.
And about the theory, the first law of thermodynamics is used as basis of calculation of heat transfer. It is also used in studying the relationship among the various form of energy and energy interaction. The first law of thermodynamics expresses that the net changes, which is increase or decrease in the total energy of the system during the process, is equal to the difference between the total energy entering the total leaving energy leaving the system during the process, which is we will see in the equation, which is energy in minus energy out equals to the difference in the energy in the system. So these are the formula where M is equals to mass, C is heat capacity, and T is temperature. So the Clausius statement states that it is impossible to construct a device or reservoir that operate in a cycle and produce no effect other than the transfer of heat from a lower temperature body to a higher temperature body. So that's all from me, Doctor. Thank you very much.
Okay, for the methodology, we for the experiment we use a kettle, a balance, some thermometers, a stopwatch, a small beaker, and big container. For the first step, we switch on the kettle to heat the water. Next, while the water to be warm, we the empty beaker was wet. The hot water fell into the beaker and the weight of the beaker was recorded. Next, after weight, we remove and place the beaker carefully into the big container. The cold water fill into the big container until reach the same level with hot water. And we make sure that the cold water did not go into the hot water or any mix from the between the hot and cold water. And then the weight of cold water used was recorded. Next, two thermometers were placed into the hot water and cold water. And lastly, the reading of the temperature for both water, for hot and cold water for every 1 minute was noted in table 1 until they reach the same temperature, or we call that thermal equilibrium.
Hi, Assalamualaikum. My name is Aida Zahira Azha and I will explain the result and discussion for this experiment. So, after the experiment conducted, table 1 show reading of hot and cold water temperature in 1 minute interval until both reach thermal equilibrium. So, initially the temperature of hot water is 85 degrees Celsius while the temperature of cold water is 28 degrees Celsius. So, after 20 minutes, the temperature of hot water dropped to 36 degrees Celsius while the temperature of cold water raised to 35 degrees Celsius. So for the data used in this experiment, first heat capacity of water equals to 4.187 kilojoules per kilogram Kelvin. Second mass of hot water used equals to 0.203 kilogram. Third mass of cold water used equals to 0.730 kilogram. So this is the graph plotted for temperature of hot and cold water versus time. So the blue line represents the temperature of hot water, while the orange line represents the temperature of cold water. So the blue dotted lines give an equation to calculate average change of hot water temperature, which is y equals to negative 1.8078x plus 64.792, while the dotted orange line y equals to 0.361x plus 21.104. So to calculate the energy change for both hot and cold water, few equations are related to each other. So firstly, the total energy change in the system equals to energy in minus energy out. So total change of internal energy in the system must be equals to 0. For this experiment, total change of energy in the system equals to change of internal energy of hot water plus change of internal energy of cold water. So equation number 4 shows how to calculate the energy change of hot and cold water. So temperature change of hot water equals to negative 49.0 degrees Celsius, while temperature change of cold water equals to 7.0 degrees Celsius. So from the data just now, we can use to calculate the energy changes for both hot and cold water. So energy change for hot water equals to negative 41.65 kilojoules, meaning the energy is released, while energy change for cold water equals to positive 21.40 kilojoules, mean energy is absorbed. So for the total energy change in the system equals to negative 20.25 kilojoules. For discussion, while experimenting, it is observed that the temperature of hot water drops more rapidly at the beginning stage compared to the temperature of cold water, which gradually increased until after 20 minutes, where both hot and cold water achieve thermal equilibrium. The transfer of energy between these two mediums obey the first law of thermodynamics, which the total energy of an isolated system is constant. Hence, energy can be transformed from one form to another, but can be neither created nor destroyed. The gradient of graphs represents the rate of temperature changes from the beginning to the end of the experiment. According to graph 1, hot water released energy as it shows a negative gradient, while cold water absorbed energy as it shows a positive gradient. The magnitude of gradients depicts that hot water released more energy compared to energy absorbed by cold water. This is because a bigger mass of cold water used compared to the hot water. Besides, the temperature of hot water decreased while cold water increased as time passed by. It shows that the heat transfer obeyed the second law of thermodynamics, which heat is transferred from high energy level to low energy level. Finally, due to this experiment being conducted in an open system, not all energy from hot medium is transferred to cold medium. Hence, some energy in the form of heat may be lost to the surrounding. So that's all from me. Thank you. So my next member will conclude this experiment.
Hello everyone, my name is Muhammad Amin bin Manap, and now I will explain to you guys about the conclusion of this experiment. In this experiment, the change in energy for hot water is a negative value because the energy of hot water is transferred out from the hot water into the cold water, while the change in energy for cold water is a positive value because the cold water receives energy from the hot water. The change in energy for the whole system, which is supposed to be zero, is negative 20.25 kilojoule. This is due to heat loss to the surrounding. Therefore, the first law of thermodynamics, which states that energy cannot be created or be destroyed, but it can transform from one form to another form is obeyed in this container if the container is well insulated. Besides that, it is found out that the heat energy is transferred from the higher energy medium to a lower energy medium, which is the second law of thermodynamics is obeyed. So, we can conclude that our experiment is success and achieve the objective. That's all from us. Thank you.